virtual LAN is a method of dividing one single broadcast domain into multiple broadcast domains. The main advantage we get with the VLANs is it's going to minimize the number of broadcasts. That is one of the major advantage it's going to provide us. And the second thing is it's going to help also in providing the layer 2 security. So let's try to understand how exactly it's going to help us in minimizing the number of broadcast domains. Like if you just get back to the basic concepts of the switching, so if you're connecting switches in the LAN, if there is one device trying to communicate with another device in the LAN, let's say there is a 192.168.1.1 trying to communicate with 192.168.1.2, a separate computer. So switches do forward the packets based on the MAC addresses. So the equivalent IP address is converted into MAC address. And then let's assume that the MAC address of 1.1 is AA and AB. And the switch forward the packets to the host forward the packets to the switch, and the switch is going to check the MAC table. And in case if the MAC table do not have the destination MAC address entry here, it's going to simply flood the information to out of all the ports. So from this we can understand that switch is a device which do initially broadcast if there is no destination entry present in the MAC table. Now switches do broadcast. So let's take an example. I got a network where I have multiple switches connected. I got a very big network, and then I got some multiple switches connected like this, and then it's connecting to router, and from the router it's connecting to LAN here. So assume that I got 200 devices connected in the LAN. So complete 200 devices. In that 200 devices, I got different departments, like I got accounts department, I got some marketing department, sales department, as well as some HR department. So each and every department having somewhere around 50 users in each and every department, and all those departments should be a part of a different network so that they should not communicate with each other. Now in order to fix that, generally what we'll do is we'll try to use different network portions, that's a different network IDs. So I'll be using 192.168.1 network here, 2.3.4, or it can be any subnetted networks, it's up to you. So I'm going to use just a default networks here. Now how it's going to work. So let's take an example. This host belongs to accounts department. Probably he's trying to communicate with some other host, and within your LAN you have multiple department users. Now initially the switch want to communicate with 1.1 and to some other host, it sends a broadcast request. Now this broadcast request goes to the switch. If the switch do not have an entry in the MAC table, it is going to do flooding, sending out of all the ports. So which means it will go to all the ports on the switch 1, also it will go to this port, from there it is going to this port, and then it will go to all the ports here, and then flood it out of this port to all the ports, again on this port, again to every port here. So now if you just try to understand here, if any one of the user who belongs to accounts is going to perform generate some broadcast request to the switch is going to send to how many devices? So assume that the switch is going to flood the information to all the remaining 199 devices, irrespective whether they are in the same network or different network. So every time a single switch generates a broadcast, it's going to send to all the devices, and that is what we call as broadcast domain. Set of devices receiving a broadcast originated by any one of the device, and by default there is only one broadcast domain on the switch. So the more bigger the size of the LAN, the more bigger the size of the broadcast domain. So if I have 200 devices connected in the LAN, if one device generates a broadcast, the broadcast goes to the remaining 199 devices. So if I'm going to take 500 devices in the LAN, one device generates a broadcast, the broadcast goes to remaining 499 devices. So it's not going to see whether they belong to the same network or in different networks. So what exactly I want here is I want to divide this broadcast domain into multiple broadcast domains. Like now the concept of this normal LAN is more similar to like take an example, you got a very big hall and you're making all the users, accounts, marketing, sales, HR, everyone is sitting in one big hall without any separation. Now there might be cases like accounts user might generate a broadcast. He shouts everyone can listen within the same hall, because it's even though they are in different networks, but they are part of one broadcast domain. So I need a solution for this, because the more bigger the size of the network, the more bigger the size of the broadcast domain, and it is definitely going to impact the performance of your networks. Now to fix this, we need a solution. So the solution is a concept of virtual LANs. Now in virtual LANs, what we are going to do is we are going to divide one single broadcast domain or one big hall divided into multiple cabins, or the multiple separation or multiple partitions, we can say, virtually separating into a separate LAN. Now once you do this, what happens is if any device generates a broadcast, the broadcast goes within that particular cabin. Just like if anyone belonging to accounts shouts, it will be only within that particular cabin. It will not be sent to other departments, and the other people, they don't actually hear at all. They don't hear at all. So that's how it's going to work. That's how the same way the concept of VLAN is also going to work. Now technically what exactly we want is we want to ensure that all the different departments should be in different networks, so that they should not communicate with each other. That is our main intention of creating them in different networks. And also what we do is we divide them into different virtual LANs, like VLAN 10, VLAN 20, VLAN 30, and VLAN 40. Now once we make them in different VLANs, now any broadcast packet generated by one device, it's going to be broadcast within the remaining 49 devices. So which means now the main reason is different networks, so that they should not communicate with each other, different VLANs, so that they should not broadcast each other. So technically this is the recommended design you need to follow when you are implementing any specific LAN networks. Okay, so one of the major advantages is it minimizes the number of broadcast packets. So that is one of the major reason, because in the production networks, when you are dealing with the very big size networks, it's not one device generates a broadcast, it's going to send to all the remaining 499 devices. It's really going to impact the performance of a network. Every time a switch receives a broadcast, it is broadcasting to each and every device in the network. So which is something I really don't want. So anyway, they are in different networks, so that they should not communicate with each other. They should not communicate with each other. At the same time, they should not broadcast each other. So if you just get back to our slides here, virtual LAN is a method of dividing a single broadcast domain. By default, there will be only one broadcast domain, and the size of the broadcast domain depends on the number of devices connected in that particular LAN. We are dividing into multiple separate broadcast domains. Okay, so it also provides layer 2 security, but the main reason of creating the VLANs is to minimize the number of broadcast messages. That's the main thing. So by default, there will be only one VLAN called VLAN 1, which means there will be only one broadcast domain, or one broadcast domain, simply we can say, that is VLAN 1. But if we want, we can create multiple broadcast domains from 2 to 1001. There is a range of the VLANs which we can create. And one more thing, this can be done only on the manageable switches. So if you're using Cisco manageable switches, probably you can only do this on manageable switches, because to create the VLANs, to verify, we need to get into the command line of the switch, and that is only possible in case of manageable switches. So the major advantage or the major benefit we can say is minimizing the number of broadcasts, because we really want to ensure that all the departments should be in different VLANs. Anyway, they are in different networks, like 10.0.2 network, 10.0.3/24. They are in different networks. Also, I want to ensure that they are in the different VLANs, like VLAN 2, VLAN 3, VLAN 4, or it can be any number from 2 to 1001. So this is a default VLAN range where every switch supports. It's going to improvise the performance of your network by minimizing the unnecessary broadcast from one VLAN to another VLAN. It's going to stop that. At the same time, it's going to add some security where The broadcast packets will not be sent to each and every port in your network. It will be restricted within your specific VLAN.